everyone, welcome to my channel. In our previous video, we have discussed the importance of data visualization, why you need to learn data visualization. Data visualization is an art and the demand for this skill is increasing day by day in the world of data-driven decision making. So in continuation to our previous discussion, I would like to talk about the topic selecting the appropriate visual. If you have a data already, if you understand your data, and if you want to create some charts. So this video is going to help you how you can get more insights from your data and what kind of chart you should use for that data. In that video we have talked about there are certain cases when we prefer not to use chart, but that is a specific topic which we will be going to cover in storytelling. As of now, we are focusing on this step, what to use. So basically which chart to use for a particular objective, for a particular data. And we are not talking any tool specific visual here. Yes, there are certain visualizations or certain charts which are specific to a particular tool. But here in this video, we are talking about the commonly used or the popular basic charts which helps you to explore your data, to explain your data most of the time. So first of all, when we start talking about selecting the chart, what are the things we need to keep in mind when selecting a chart? Basically, why we create visual? We create a visual for two purposes. One is for exploratory data analysis, which we call ADA also. So if you are a research scholar or analyst or data scientist, you might be spending good amount of time in exploring your data, understanding your data, finding out the patterns, looking at the distributions, finding out the relationship between the variables or the composition of the variables. So if you don't know these insights of the data, but you are trying to explore and you are trying to explore finding out the important features in your data, you are trying to find out some insights to fill up your missing values, or you are trying to understand your data to perform data pre-processing before you put it into ML algorithm to create new features, something like that, then it becomes very important that you understand selecting the right chart so that you get more insight. Even though there are many tools these days which helps you to perform auto EDA or auto viz, but I would say that you can use automated tools only when you know clearly what to do with those tools. For example, you have performed auto EDA using pandas profiling, and you can do auto EDA in other tools also. So it will produce some of the charts for you, but you should have an understanding that how to interpret those charts and in what situations using that chart is appropriate. So in the current video, we are focusing on selecting the right chart for your data, for your objective. And as I said, you can also use it for another purpose, which is explanatory data analysis. This word is not that common, but name itself is very clear. When you want to explain your results, when you want to explain your findings to someone, if you already have a story which you want to tell to someone about your data, if you want to share your insights about your data, so then you are in the space of explanatory data analysis. There also you need charts, but depending upon your objective, your audience, your context, and many other things, like you are explaining it live or you are explaining it in a report or through an email. So there are many things which gets changed when we come to the space of explanatory data analysis, and we will talk more about this in our subsequent videos on storytelling. But as of now, we are focusing on how to select the right chart most of the time which are useful for EDA. Definitely those charts you can use in explanatory space also, but at times depending upon context you might need to focus on one particular aspect of that chart. You might need to change the design of that chart. You might need to change it to a different chart, as we have discussed that for a single data set there are many options of charts which you can choose from, And even for the same objective, everything same, then too you have multiple options. So we will talk about all those things as we will move forward in the series. If you are a beginner, so take it very slow and learn it step by step. So we are starting our discussion with exploratory data analysis using visualization. And exploratory data analysis can be done in other ways also, like looking at the summaries, looking at some hypothesis test. So those topics we would be covering in a separate playlist which is dedicated for exploratory data analysis. Now enough of talking, let's move to the topic. When we say you need to select the right chart, it also depends on, let me write in this slide only, it also depends on few things. One thing it depends on is data. You must have an understanding of data types, at least the numerical and categorical variable, or if your data is cross-sectional or time series data. So a basic understanding of your data will help you to select the right chart. Secondly, you must have an understanding and a clear understanding of objective, what you are trying to do with that data, what you are trying to explore or what you are trying to explain with that data. So if you are looking at the distribution, are you interested in finding out whether the data is normally distributed or not? Or are you interested in finding out the relationship between two variables or many other objectives? We will talk about those. And of course, it depends on context and audience, which we have just introduced to you. But these two topics we will discuss in greater detail when we will be talking about storytelling with data later in the series. As of now, we would be focusing on these two, data and objective, to understand how we can select the right chart. Now let's talk about how we can use data types and objective to select the right chart. So first of all, assume that you have just one categorical variable. For example, gender, then what chart you can use to represent its composition. So you might say pie chart or bar chart. So pie chart, donut chart, these are the most hated chart these days. So I would suggest to avoid those charts. But yes, you can use if you use it correctly. But I prefer to avoid pie charts. Why? So I'm not discussing it right now. It would be a lengthy discussion. But I would suggest to use bar chart in that case. So bar chart, sometimes people also call it column chart. So it basically looks like this. You have two bars. If you have two categories of gender, male and females, you have two bars. And if three categories, you can have three different bars here. So this is how it looks like, bar chart. And obviously when we say that we use bar chart for one categorical variable, so here we have categories of that categorical variable on x-axis. What we have on y-axis, when you look at the visual, I would say always focus on what is there on x-axis, what is there on y-axis. Then only you will be able to interpret or read the chart quickly. So it's very simple. In case of bar chart, here you have count usually. So in a data set, how many males are there, how many females are there. Obviously, it doesn't make sense if you have just a single data point. For example, you're asking my gender, I'm saying I'm a female. It doesn't make any sense to plot any graph for this data because it's a single data point. But if you have multiple data points in a population of 100, you have suppose 40 males and 60 females, then it would be making some sense to represent those using a bar chart. So you can have counts here on the y-axis. Otherwise, you can also have here a percentage on the y-axis. Out of total population, how much percent is there in males and how much is there in females. So basically, what you are looking at here, you're just looking at composition of that variable. Means you have a categorical variable and how it is having the composition for different categories. And basically, if you represent the same information in the form of a table, what you have a frequency table, which is the very first topic of your statistic textbook, the variable gender, male and female. And here you write count. So it becomes a frequency table. Here suppose 40 and 60, it's a frequency table. And definitely you have percentage frequency table, you have cumulative frequency table, all those things. Totals also. Or graphically you can represent the same information using the bar chart, where the numbers represent either the count or percentage. And of course we can flip the coordinate axis and we can make a chart like this. Here we have males and here we have females. It's the same information in the flipped coordinate or maybe in the form of horizontal bar chart. The same information, just that it depends upon which one is easy to read. We will talk about all these things later, what should be there, and how to choose the scale, and whether we should prefer horizontal or vertical bar chart. We will be talking about all these minute details in the current video. Now let's quickly understand other charts. We would not be discussing in that much detail. We would be just showing what all charts you can use for different things. So here, for one variable, for this objective, one categorical variable and objective is composition, we have shown you that you can use bar chart. Now, if you have two categorical variables, means you are interested in finding out the association between two variables. For example, you have gender and you have salary or income groups. Let me write salary range. So suppose your objective is to check whether these two variables are associated with each other. In other terms, your objective is to check whether salary is gender neutral or is there equality. Suppose we are talking about a particular company or an industry, so we want to see whether the salary range is same for both genders, or maybe if we include third gender also, so whether it is the same. Because we see every day the stories from Bollywood also that they claim that there is not gender equality, they pay more to actors than to actresses. So if we collect data on for multiple entertainers and note down their gender, note down their salary range, keeping in mind that other variables are same. Otherwise, there are so many factors which affect the salary range. If all other factors are same for a group and we want to study that population and we want to see whether there is an association between those or not, then we can use stacked bar chart or grouped bar chart. Stacked bar chart means you will be having stacked like this. So here, suppose you are representing male and female. Earlier you were having just two bars for male and females, right? It's like this. Now, apart from these two bars, you would also be having text which would be representing the salary range. Suppose you have the cutoff here. This is low, medium, high. So you represent that out of those males, these many are there in low salary range, these many in medium, and these many in high salary range. And similarly in females, you have some stats which are for low, medium, and high. So this is a stacked bar chart. It's not that easy to read those stacked bar charts, so at times we use percentages to basically 100% chart to make it easy to read. We will discuss the interpretation in a separate video, and otherwise you can make a grouped bar chart like this also. So these are the groups for males, and similarly these are the groups for females. So low, and there are too many in medium, and there are good and high also. Just it's not the actual data, it's just a rough sketch to show you how it looks like. So low, medium, and high. So we get an idea about how the salary range is distributed in male and female groups. Are they looking similar, or do we have any difference? So we get a rough idea about the association between the variables. But basically in exploratory data analysis, if you're trying to get insight, you cannot just rely on the plots. You need to look at the numerical summaries also, and you need to look at the statistical test also. So here you use cross tabulation numerically. In whatever software you are using, there are ways to compute the cross tabulation, basically a 2x2 table where you have gender here, so male and female, and you have salary range here, so low, medium, and high, and you have cross tabulation. So you see the relationship there. Definitely there are marginal percentage in all sort of cross tabulation, and you can look at some statistical test, and the very popular test is chi-square test, but there are many which you need to read about when you go for that. Fisher's exact and Kramer's v-value and phi and all those things. But as of now, for visuals, you have these two visuals, stacked and grouped bar chart. And at times it depends. If you have time series data, you can use line charts also. Now Let's talk about if you have numerical variable. What you can do if you have one numerical variable. Basically, when you have one numerical variable, what can be your objective? Suppose you have a data for age of 100 participants in a study. What you will do with that data? What you want to explore with that data? So basically, you want to see the distribution of data. Distribution means you want to see the average value, you want to look at the variation, you want to look at the skewness, you basically want to see whether the distribution looks symmetric or it has a skewed. So these kind of things you want to explore. And for exploring these kind of things, the plotting options are histogram and density plot. We also call it frequency curve and box plot. These three plots will give you information about the distribution of data. And now I'm not discussing the interpretation part, otherwise it would become very lengthy discussion. So you can look at this kind of histogram, and if you plot density plot, it looks like this for this data. And definitely you can have this kind of a box. And if you flip coordinate axis, it becomes this kind of a box plot. If you create histogram, basically here are your bins on y-axis because it's a continuous variable. Then we have probability density here. Also, if you have just one numerical variable, but the numerical variable is time dependent, and if you are looking at the pattern, basically time series data, and if you are looking at the pattern, then you might use line chart here, which shows you how the variable changes with respect to time. Now let's talk about two numerical variables. So when you have two numerical variables, you are interested in finding out the relationship between the variables most of the time. Sometimes you are interested in comparing the variables, how they behave with respect to each other, and sometimes you are interested in looking at the pattern of both variables with respect to time. So depending upon your objective, you will choose the visual. So if you want to find out patterns into numerical variable, again you can use line chart. This time you can use multiple lines, 2 lines for 2 numerical variable and 5 lines for 5 numerical variables. Suppose you are looking at COVID-19 cases in a particular country, so your graph would be looking like this, unfortunately increasing. If you look at recovery rate, also in the same chart, so you can use a different colored line here in the same chart. Maybe earlier your recovery rate was low and it's increasing also. If you look at death rate also, so it's another variable you can include in the same chart here again. So depending upon how many variables you have, you can plot multiple lines. But when you have multiple lines, there are a few things to keep in mind about scales and comparison. As of now, you see that if you want to see patterns in the data with respect to time, we use line chart. Now, if you are comparing to numerical variables, what you can do is you can plot the histogram or the density plot of both the variables on the same chart. So you will get an idea how both the variables are behaving. So maybe you have two variables, age and weight, and you see the distribution that both are symmetric, but their average values are different. Or maybe some other variable, third variable. So if you have multiple variables and you are just looking at their comparative distribution, you can put them in the same graph. And you will see that this variable, the third variable, is skewed, right is skewed. These are symmetric but having different average values. You can compare their variation also. Now, if you are interested in finding out the relationship between the two numerical variables, it is commonly used. If you want to perform whether this variable is having an impact on other variable or not, so those kind of objective, you use scatter plot. You have two numerical variables, suppose height and weight, whatever. And you get an idea about how these variables are related. There are so many things to talk about how to read the scatter plot. We can have linear or non-linear pattern. We can have monotonous relationship. We can have a different type of measures when we talk about a scatter plot, different type of correlation measures. So all those things you need to read about. But if you are just selecting the right chart for two numerical variable, looking at the relationship, so scatter plot is the right chart. Another way of looking at this is if you have two numerical variable here, x and y, and these two numerical variables behaves differently in presence of another categorical variable. So in that case also it becomes useful to use size shape, color, these aesthetics. So if you use size, shape, color aesthetics in whatever tool you are working with, basically you will be able to show two numerical variables which are there on x and y axis and up to three categorical variables. So for one categorical variables you have different sizes, for another categorical variable you have different shapes, and for the third categorical variables you have different colors for different categories of that variable, right? So in the same chart you can show up to 5 variables, and you need to see whether it is readable or not for that particular data, but you can pretty much do it in most of the tools available there. And when we do that, we call it bubble chart. It's nothing but the scatter plot by using some aesthetics, so we call it bubble chart. I'll show you how pretty it looks like. And you can add even more variables, 2 more variables, but let's skip talking about that right now. Let me show you bubble chart. So here you have weight and MPG. Basically this chart I have created using R, and it's the relationship between these two numerical variables. So I have used the inbuilt empty cast data set in that software. You can do it for any data set using any software. So here we see the relationship between weight and MPG. And if we just look at this, we see that, okay, it's the data set of cars and MPG represents mileage per gallon. So we see that as the weight of the car increases, mileage decreases. And we know it's that heavier cars tend to have low mileage. This is the data set which I have used. So in this data set you can see that MPG is the first column, which is a numerical variable, and we have plotted it with respect to weight, which is again a numerical variable. Now if we want to use more information about the categorical variable also, in this data set we have so many categorical variables also. So cylinder is another categorical variable which represents how many cylinders do you have in the car. 4, 6 and 8, 3 categories are there, and displacement, HP, these are numerical, QSEC is numerical. These are categorical variables again. This VS which shows I think engine type, so 2 types of engine there. AM shows whether it is an automatic vehicle or manual gear vehicle, and it's there. And gear shows number of gears in the car, so you have 3, 4 or 5 gears, 3 categories here. And again it is some variable, I don't remember. So basically we will see in next few slides that how we can plot MPG versus weight or weight versus MPG, including 1 or 2 or 3 categorical variables in the same chart, and can we read that. So this is a very small data set for practice with just 32 rows and 11 columns. So I have quickly created these plots to show you. You see that here we have included one more variable which is cylinder variable. So this is cylinder variable here, cylinder variable here, and these are 3 categories, 4, 6 and 8. And you see here that these are the red colors are for 4 cylinder cars, 6 for this and blue for this. So in the same chart we are getting an information that for 8 cylinder cars weight is in the higher range, right? And for 6 cylinder cars it's in the middle, and for less than for 4 cylinder car weight is in the lower range, which we expect also. More cylinder, more the weight of the car. And we also see the pattern about the relationship between weight and MPG for that category. So weight and MPG for 4 cylinder cars here is decreasing drastically. So you see here, if you plot a straight line here, the slope is very high. But if you look at this category 6, it's not that clear. The slope is not that high and it's not that clear. Probably because we have less data for 6 cylinder cars, so we can't make a conclusion here. But we see we have different patterns for different groups that we can read it from this plot. So reading the plot, I'm not spending too much time. I just try to give you some idea what you can do if you have multiple categorical variables in a scatter plot. So here we have included one more, which is AM variable, and it's having 2 categories. So we have represented it with 0 and 1. 0 and 1 we have represented with circle and triangle. So you see here this triangle represent automatic vehicle and this circle represent manual vehicle, and the same plot with some additional information. And if we have one more variable here, gear, so this time we have changed the size of the markers. So we have different size here and we can plot. In this plot, we have included 3 categorical variables apart from 2 numerical variable, and we call it bubble chart. And let me just show you that sometimes it becomes difficult to read that bubble chart. So in different tools you have some libraries which helps you to plot interactive graphs. For example, this chart, the same bubble chart I have plotted, and what you can do is weight and MPG. If you take your cursor there, you can read those data points, what's the MPG, weight and all those variables there, and you can pretty much look at a particular portion if you are just interested in looking at this portion. So you can zoom this and you can read it carefully. So different tools give you a lot of flexibility to play around with interactive visuals. For example, you see very nice pretty visuals on Gapminder. So you look at here, this is the same type of chart, bubble chart, life expectancy and income. So if you are looking at this chart and if you are wondering how you can create this, first of all you should have a basics of how you use scatter plot and how you use different variables. So you can play around this link and you can see it looks very pretty. Okay, now coming back to our topic here, we were talking about selecting the right chart. Next, if we have one numerical variable and one categorical variable, then we use box plot. We are interested in looking at the distribution of numerical variable for different categories of categorical variable. So that's the objective, and we use side-by-side box plot. We also call it side-by-side box plot at times. So we have different boxes for different categories. For example, this box we have for males and we have this box for females. This is the median. So whatever we are talking about, median value is higher for males than for females. You can look at the variation also. You can also look at the outliers in the groups, that females have some outliers, males don't have some outliers. And I think we have covered pretty much all those common plots which we use for numerical and categorical variables. There are some other visuals also. For example, you might have come across some visuals like scatter plot matrix. Suppose you have more than 2 numerical variables, as we have seen in that empty class dataset. So you have variables x1, x2, x3, suppose at 10 numerical variables, and you want to see the relationship between each pair of variables. So basically you need plot between x1 and x2, x1 and x3, plot between x1 and x10, and all possible pairs. So basically density plots you want to see. Then you can create a scatter plot matrix by using most of the software, and it will just create a matrix like this where you have all the variables on x-axis, same variables on y-axis. For example, you have x1 here, x2 here, x3 here, x4 here. Similarly, you have x1, x2, x3 and so on. And you have some plots here. The diagonals are always perfectly linear. This is nothing but a matrix of scatter plots between pairs of variables. For example, this is the plot between x1 and x1. Here we see x1 in the row and x1 in the column. We have the plot between same variables on both axes, and definitely it's going to be perfectly linear because we are plotting the same variable on both axes. And if we read this plot, basically look at the row here, this is x2. So on x-axis we have x2. On y-axis we have the variable which is there on the respective column, x1. So this is the plot between x1 and x2. And here if we read, we have x3 on x-axis, we have x1 here. So this kind of plot. So here we have reverse relationship x2 and x1. So if we get this here, we would be getting this kind of a relationship here. So you can just read the upper triangle matrix or the lower triangular matrix to get an insight about relationship between pair of variables. That is one thing you can do. Another thing is you can talk about parallelogram, in which what we have is if we compute a correlation matrix between different variables. So we have some variables x1, x2 up to whatever number of variables you have here, and you can compute the correlation between those. Now, what kind of correlation? That's a separate topic. But you have a table. Suppose you have a table of 10 by 10. And if you read that table, it's not that easy to read a 10 by 10 table and to identify. Definitely you can use conditional formatting if you are reading it in Excel, and that helps you to quickly catch about some focus points, the highest correlation, the lowest correlation, or the negative correlation. And same we can do in any software, we call it heat map. I'll show you in a while how it looks like. And there are some other plots like waterfall chart. So sometimes it's not that easy to read stacked bar plots. We prefer waterfall charts. Sometimes when you have hierarchical relationship, then you can use tree map or decision tree diagram or maybe dendrogram, and definitely you can use some other fancy charts and some tool specific charts also, like pen chart and swarm plot, and you might be wondering when to use boiling plot and jitter. I would suggest you, if you are a beginner, first get a mastery on these basic charts, when to use which, how to interpret, and definitely how to create that in the tool which you are using. Then only look at these fancy charts, and you will find those charts are very easy to read. So let me just quickly show you how heat map looks like. So heat maps looks like something like this. You can read this chart. So you get a color coding here basically. So red color shows some range and blue color shows negative range, and in between you see white. So lighter shades means lower numerical value, darker shade means higher numerical value, and red and blue separates the positive and negative numerical values. So you can use heat map much with the table or with the correlation matrix. So different ways you can use different charts. Now in the upcoming video we will be also talking about the art of selecting the right chart in greater detail. For example, the same data set which we have shown here can be represented by using a line chart. And this is the example of a storytelling which I have taken from the book of Cole, which I have read recently. But I'll show you all these different type of chart. Like this is a table view dashboard. So instead of showing this dashboard to your audience, if you create a dashboard like this, it looks much better than that, and you can read it in a better way. So we will show you some good visuals, bad visuals, and if you have multiple options, what to do. And definitely there are many other things to tell you, and you can use interactivity to make your chart more understandable. In the upcoming video, we will be talking about particular chart type, its interpretation, how to make it good, the design aspect, how you can declutter, how you can present it differently to different audience for different objective. All these issues we will be talking about in our subsequent videos. Stay tuned. Thank you for watching.